Hello, my name is Orsam Hashim, and today me and my group are here to analyze how groups of golf earnings can significantly vary. Throughout our model, we attempt to provide data that will give suggestions on what to add in order to obtain a precise look at earnings. By looking at the data provided in Table 1, we make an effective use of all the variables given. Statistical analysis. We determined that our dependent variable was earnings, followed by a more in-depth explanation shown in Table 2. With an approximate minimum of $800,000 and a maximum of $6.5 million for earnings, we attempt to understand why the discrepancies between players are so large, and what model can accurately give us a strong prediction of players' earnings in the future. We can expect a non-normal distribution of earnings as the mean, median, and mode all differ. This is further demonstrated by Figure 1, where unimodal and right skew distribution of players' earnings can clearly be seen. As shown in Table 3, a player's average score seems to have the most substantial impact on earnings amongst all their given variables. Although there's a strong relationship between our independence, driving distance, and drive accuracy. However, considering that there has been a set correlation threshold of plus or minus 0.70, we can determine that there is no presence of multicollinearity in our dataset. For this reason, we can comfortably conclude that our independent variables are able to maintain their individual sovereignty and thus do as they please. In Figure 2, we will attempt to predict earnings using only average score. A player's average score and their earnings share a negative linear relationship, meaning earnings will decrease as their average score increases. Using the population regression model provided in our report, we would assume that the highest potential earning for a professional golfer based on our model with an average score of 55 would approximately be $20 million. Figure 1 and 2 really emphasize how golf is a very close in numbers game. With only a few more strokes added to a player's average score, their earnings can significantly vary. Although other variables may be at play, we determined that a lower average score can increase earnings and vice versa. Thank you.
Okay, so in golf, there is a threshold called a cut. Generally, a tournament is 4 rounds and it's performed over a weekend. And after the first 2 rounds, there is a cut between the players. So it depends on what type of strokes you're going into the third and fourth round are. So on that hand, that's of how the winnings get split up. So, and then you're guaranteed a portion of riches at the end if you make that cut. The best exemplified in the Greatest Golf Tour is the PGA Tour. And the PGA Tour, attending athletes earn an average and they get an average cut, but if they fall short, then they do not get a chance to or even get a significant lump sum of the money that because they're off by just a couple of strokes. So golfers don't have that much wiggle room and they have to make it work between if they could be just one score that gets them cut so that they don't get a chance at that lump sum. Having said all that, the average golf score is significant in the game. However, can it help predict a player's earnings? It can help with it for sure. Looking at our population regression model to predict our dependent variables, which we could tell from that our R squared value was only 19.65% of the change in earnings and can be explained by the difference in the player's score, which is what I talked about a couple of minutes ago. This can be in turn be used to say that Figure 2 would not be a good fit when it comes to predicting earnings, but regardless of its overall importance to the game itself. So what if we were to increase the breadth of our independent variable and the amount to remedy the situation? To answer that question, we performed 2 additional analysis, one model including all of our independent variables and another reduced version including both greens in regulation and distance and drive. That ended up resulting in a reduced model, and we can predict 33.9% and 33.22% change in earnings respectively. So overall, both models are marked improvement when compared to the first model. Therefore, our F test shows that there is no significant variation between the full model and the reduced model, and that is respectively, resulting in a 0.68% difference. And that we can, so from conclusion of that, we can confidently say that our reduced model is our preferred model. So further our conclusion on our whole entire project, ultimately the reduced model is the least complex of the two, and it's able to predict a 33.22% change in earnings using the variable average score. And that also includes the sand saves and the drive accuracy that we added in there as well. However, that is very low bar to meet, and our preferred model is insufficient when it comes to accuracy. The addition of more independent variables may improve the situation. Most of our variables in our data set show the ball-first ability to hit it into the correct places, which that doesn't always help with determining of how accurate and of how good they are as a golfer as a whole. Therefore, variables like with putting, like adding more putting would make it a lot easier for us to have more accuracy to predict. So like having like a average putts per round in addition to average feet of putts made per round. The and also determine the golfer's distance of their successful putts, whereas the performance, it just shows average putts. So that way it would get a little more in depth, and that would help out quite a bit as well. We could also use strokes gained tee to hit and scrambling as two other factors that we could use as well. In addition to the independent variables, that would help us a lot deeper on this topic. Detailed understanding into the effect they would have on the golf's earnings, and hopefully that would mean we'd be a step closer to achieving our weekend warrior dreams. So that's what we found from our presentation.